I'd like to welcome now Geosley Andrades. Geosley is a product evangelist and community builder at ACCELQ. Geosley has been working around for 15 years of experience in the software testing industry. It is great. Geosley would be speaking on AI Friend or Foe, demystifying its implications for testing. To know more about him and to watch his video interview, please check the following link. Over to you, sir.
Okay, sir. Now I will stop sharing and you can take over.
Thank you so much, Isha, for the introduction. Can you please confirm if you can see my screen?
Yes, sir, we can see.
Okay. So, yeah, let's get started. So welcome everyone for my talk. I'll be talking about AI Friend or Foe, demystifying its implications for testing. About me, I'm a product evangelist at XLQ, and I also lead the Q community, which is a global community of test automation enthusiasts. So I'm a tester by heart and driven by community. I have over 15 years of experience. I'm an AWS certified solutions architect, certified Scrum Master, certified Agile leader. So if you'd like to connect more on these topics, you can definitely reach out to me after my talk. So getting started, what is artificial intelligence? Artificial intelligence is the science of making machines do things that would require intelligence if done by humans. So looking at artificial intelligence as a whole, artificial intelligence is to enable computers to mimic human behavior. And if you look at the subset, which is machine learning, that is the subset of AI, which is using statistical methods to enable machines to improve experiences. A subset of ML is called deep learning, which uses algorithms inspired by the function of the human brain. So deep learning algorithms are specifically more with intensive computations and require millions of data points. When you talk about machine learning, we do have supervised and unsupervised learning, where we see about supervised, which is highly accurate and uses labeled data, whereas unsupervised learning has data which is not labeled, and the computations are complex and little lesser accurate when we talk about supervised learning. So this is one example of a deep learning model, which is ChatGPT, which is being very popular right now and in social media. So I did ask it to write a poem about myself, and it was pretty accurate to write a very nice poem for me. So do check this out and do check out ChatGPT. So why are we talking about AI and demystifying its implications for testing? So if you look at the Gartner stats, in the 1980s, we started more with manual testing, or what we call as experiential level exploratory testing, and then slowly evolved to early test automation, and then went on to browser automation, and then continuous testing or DevOps, which started the wave in 2010. But if you look at the latest things of what's happening today in 2020, there's a lot of focus, which Gartner states, towards AI augmented testing. And the reason for adoption of this is because of higher test efficiency, ability to tackle technical complex problems and real-time use cases, and more importantly, to reduce the delivery cycle time. So this is a stats done by Forrester, which was a commissioned study along with Keysight, where the stats said that there are 84% of the projects which are really very complex, but only 11% of them actually use AI for their testing or integration purposes, which is quite a low number, right? In terms of the survey, there was a very promising need with the adoption of AI, where 45% of the leaders did consider in the next 3 years to get more closer to adopting AI-specific techniques, and 52% also would like to use AI for complex test suites. So this is very promising for us when it comes to smarter automation with the power of AI. Now, why is all this getting a lot of scope and momentum? It is because AI today is everywhere, right? You see when you look at assistants like Alexa, Google, Siri, all of these use AI. If you look at personalization like Netflix or Prime, Amazon Prime, right, where they suggest you recommended movies or recommendation engines. All of them in the background are using AI. When you look at image filters or video filters that you're going to click, these also use a lot of AI into it. Weather forecasting, pest detection, crop monitoring today are also leveraging the power of AI. Face detection, very much most of this you will find in mobile phones and smartphones today. When it comes to security, fraud prevention, this is also in the background using a lot of AI. And of course, not to forget medicine, when it comes to cancer detection, medical imaging, they also use AI into their tools and machines that are used there. So while we're looking at a lot of AI that is out there, I wanted to specifically concentrate more into the AI and demystifying its implication for testing. So in today's talk, I'll be covering about element identification. I'll be talking about action logic creation, discovering new tests, visual testing, self-healing, test data generation, and result collation, all using the power of AI. So element identification, the first thing that comes to your mind, when we talk about traditional way of element identification, it has always been, using developer tools, finding the XPaths, or using some sort of a plugin to find out these particular element locations. But when you talk about modern ways of leveraging AI to do element identification, there are a lot of algorithms that run in the background, which pass through your DOM structure and easily identify them without you actually trying to identify the XPath or the CSS selectors. So more in terms of a quick demo around what happens in the background and what algorithms are used, there are decision trees which are used in the background, which are using to detect and identify objects. Like if you see this particular image of football players, is identifying the football players. This one, which is of an airport, where it's identifying the bus, truck, and aeroplane. So in the background, what is actually happening and what is all the AI all about when it comes to talking about element identification? So AI is not about, going into dev tools and putting the XPath and, fetching it for you, right? So all of these happens actually intelligently. And what are the algorithms running behind in the background? So I'll try to, uncover a few of them. Obviously, there are a lot more that get into the background, but the first one, when it comes to element identification, is something called a decision tree. It looks at, having a root node, then a subtree, and then leaf nodes, right? So to say it in layman language, what this decision tree does is that, in the example in the right, where I say I want to identify oranges, right? So I have a box or a basket full of fruits, and then I categorize the ones which are smaller or less greater than or equal to 3. So I flush out cherries from there. And then I take a decision whether the fruit is orange in color, and that's how I'm able to identify oranges, right? So this algorithm is primarily used when it comes to element identification in such AI-driven platforms. The other algorithm that is popularly used is KNN analysis, which is also known as K nearest neighbor. So say for this grayed out image, you're trying to identify what this image is or what this element is, right? So what KNN does is it gets into the cluster, it tries to identify what are the probable data sets it has, right? So in this example, if you see the grayed out image, there is 2 images of Jerry and 1 image of Tom, right? So in terms of the nearest neighbor, there are 2 nearest neighbors, which are Jerry here. So the AI algorithm identifies that the image that you're looking for, or the object that you're trying to identify, or the element you're trying to identify is actually Jerry. So let's talk about the next one, which is action logic creation, right? Traditionally, when you look at action logic or test authoring, right, we normally have to write, if you take this example of Selenium and the code is Python, you have to import the web drivers, you have to induce and find elements, find XPaths, right? So this has been previously very much complex in terms of knowing to code. You need to know languages like Python, Java, C#, Ruby, etc., right? But when it comes to using and leveraging the power of AI, this 24-line piece of code is now reduced to just 3 lines, where you're just using natural language and just writing in a notepad like editor right now, where you're entering the username, entering the password. There are natural language editors which help you easily interact with PDFs, databases, and suggest you based on what you want to do, right? So here's a quick demo on the algorithms that get into, and here I'm trying to showcase a demo of the AI API, which is trying to find out the similar sentence in this using natural language processing. So this is a happy person. So this AI is able to identify that the second sentence, which is this is a happy person, has a 94 probability that it is related to what we're trying to write. So these AI platforms today use natural language processing to identify similar set of test authoring steps to help you easily automate. So what's happening in the background and what's happening behind the scenes, we're using actually something called as natural language processing, which is natural language understanding and natural language generation. So when it comes to natural language understanding, lexical ambiguity, right? It's when words can carry out different meanings. So your algorithm is so trained to understand what it actually means. So if you see this example, he's looking for a match, right? The match can be a partner, a match can be a cricket match, a football match. So what match it is actually, right? So the algorithms are trained in such a way to identify and remove and easily understand the ambiguity between this, right? The other example of synthetical ambiguity, right? So Feluda met Topsy and Joytu, and they went to a restaurant. Now, what is they being referred here, right? It could be more, it can have more than one meaning here. It could be Topsy, it could be Jaitu, or it could be all of them going to a restaurant. So the AI algorithms do synthetical ambiguity and analysis to identify what your writing and authoring actually mean, right? So some examples, like a brick fell on your computer or your laptop, right? And it is broken. Now, what is it referred here? Is it a brick or a computer? So there is some sort of a referential ambiguity. You don't know what it is, right? So these algorithms actually help you intelligently figure out what you are typing in natural English language and relate to what you actually want to do and automate or author, right? When you talk about natural language generation, it's more about the algorithm takes in inputs and keywords, right? What you want to do with a particular thing, right? This is more taking a bus from Herald Square to Wall Street at 9 a.m. So you give the inputs to the algorithm, and the algorithm generates NLG for you. So where you can see in this example, it has generated a proper sentence that there is a bus at 9 a.m. from Wall Street to Herald using line M102. The other application when you talk about AI is discovering new tests, right? So traditionally, how have we been discovering new tests, right? We have been using Excel files. We have been writing out our test strategies in a test plan and things like that, right? So what is a modern way of discovering tests, right? So this is an example of agent AI generation exploration in test, where it is skimming through the application platform, exploring the entire website and evaluating running tests, fields and forms on this particular platform and giving you the collated result that you see on the screen here. So this is the modern way of discovering tests right now, and no longer you don't need to have Excels and stuff like that. So if you're interested to know more about this project, you can go to the GitHub profile I mentioned of Tariq King/agent, where you will get the idea of this particular project. So what is happening in the background? It is basically you're trying to train a neural network model, right? This is from a research article from ACM Digital Library. So what is the neural network model actually doing? It is perceiving, it is acting, and it is observing, right? So perceiving is understanding what the environment is and what possible actions you can take on that environment. Like, for example, login screen, right? So this is a screen that I have now. So the neural network model perceives that, okay, I need to log in, right? And then what all actions you can get onto that. So click on sign in button, say, for example. And what are the observations can this neural network model do, or what all test flows that it can generate, right? So in terms of verifying if an error message, verifying if it's a success message. So neural network models work on these event sequence of perceive, act, and observe, right? So if you see the example on the right where I'm talking about first name, middle name, right? Entering data. So the neural network model perceives that there are two text boxes, and then it acts saying, okay, let's try a valid first name, and maybe just click on save, and then you observe an error message because maybe middle name is missing or middle name is blank, right? In this case, if you enter every field, there you say not observe error message, right? If you enter a blank first name, you will observe an error message. If you enter a blank middle name, you'll observe an error message saying middle name, or an error message saying, okay, middle name is missing. So in terms of all of these computations, you're actually training a neural network model in the background, right? The other application when you talk about testing, it's about visual testing, is where AI can be really useful for us as testers, right? How has it been happening traditionally when it comes to visual testing, right? We used to do kind of pixel to pixel kind of testing comparisons, right? Now, the problem with this pixel to pixel comparisons is if there is a slight deviation in terms of the image, right, you get a problem of anti-aliasing, right? If you see the example here of playlist and playlist, there is a 1 pixel difference, but if you see the difference being thrown out by a pixel comparator, says that, okay, everything is a visual error, right? When it is not actually. And the other way that we used to traditionally do visual testing, used to write assertions. So for example, you want to check if the element is visible, element is at particular coordinates, the height, width, background color. We needed to write code, right? And then if you look at, say, like in your page, you have 20 visual elements, you are writing 100 lines of assertion code, which is way too much, right? Just imagine when you want to run this on 30 different platforms, browsers, you have to write 60 unique configurations. And the horror comes in when you have 100 screens in an application, right? You're writing 60,000 unique configurations. That's way too much, right? So it's time that we now leverage AI for such kind of comparisons. So this is an example of a platform which uses the power of AI to actually identify even slight pixel comparisons, which may not be and will be difficult for even a human eye to identify. So let's look at a demo of image classification. So when you look at images, what the algorithm does is it uses computer vision, and it tries to identify what is the probable picture that you can see on the screen. So this is of a teapot, where it says, okay, 98% it's a teapot. Now, if you look at this image, which is of an API, image classification API, you can see that it's giving like, okay, hey, 99%, this image is of a palace, right? So what is all happening in the background, and what is the real AI behind these visual comparisons, right? It's basically using the idea of computer vision, which is, dividing your image into various pixels and giving it a value from 0 to 2 to 5. So this is a black and white image, probably you can say of Abraham Lincoln. But when it comes to a black and white image, it grades each pixel to have a value from 0 to 2 to 255, right? And the computations start to increase and get even more complex when you add RGB images or colorful images, right? Where you have to store 3 values in a pixel, right? For R, G, and B. Similarly, from 0 to 255, right? The advance of computer vision, what happens is it uses convolution, pooling, and fully connected algorithms to predict an output there, right? So if you look at this particular vision, okay, or this image of a boat, right? What happens in convolution? It splits the image into smaller images. Then it runs it through a filter, and it tries to identify what this small image is all about, right? And eventually, after it does a lot of convolution, which is splitting, and pooling, which is identifying, it forms a fully connected network to identify what this image is all about, right? So as the output of splitting an image, running your filters, which is pooling, it identifies, okay, hey, this image looks to be 94% of a boat, right? So that's how behind the scenes these algorithms work when it comes to visual testing. Fifth one, which is very popular, which is self-healing, right? And it's very in the need of the hour, because maintenance has always been a nightmare for us all the while, right? Now, traditionally, these methods of using self-healing have been really very shallow, where we are using if-else loop. If release this, then use this XPath. If release this, then use this XPath. Or probably just pointing our the object locators to a different source, right? Depending on the release. But this is not how AI actually works, right? So when you want to leverage the power of AI, it actually identifies what actually has changed, and it gives you and helps you go ahead and progress with your test. So today in this state, maintenance is no longer a hurdle. And this the other report that you see here is even Selenium, which is Selenium is also adopted to use self-healings there, right? So AI adoption has been increasing even in open source platforms today. So what's happening in the background? It uses multi-class, multi-labeling algorithms to identify what exactly the object that you're referring to perform an action on. So multi-class is basically telling, okay, in this image, which is the image that you see more dominant. So you can say this is, hey, this looks to be an image of a dog, right? And multi-label is like, hey, what all other dominant images you can see? So I can see an image of a dog and a plant, right? So all of these algorithms are used to identify and self-heal your objects in real time, right? The other thing, what is used behind the scenes is also called K-means clustering algorithm, right? So you have unlabeled data, or you don't know what that data is, and then you label it to identify, hey, this looks to be a sign-in button, or hey, this looks to be a username button. So if you look at this particular example where you see birds and fishes, right? It runs through a K-means clustering algorithm, and then it splits up into various clusters. Okay, hey, this looks to be all the fishes, and hey, this looks to be all the birds, right? So that's how self-healing actually works in the background, and that's what true self-healing actually means when we talk about leveraging the power of AI. The sixth one is test data generation. Now, traditionally, the way that we generated test data was very shallow. You used random classes in Java or jQuery APIs in Java that used to randomly generate names, right? Now, true AI is not using random generators, right? True AI is classifying what data to actually go in there. True AI is actually predicting for you and generating test cases for you with the test data that can be there within that field, right? So here is a demo of a fill mask API, which I'm showing you right now. So here you want to say that, okay, Paris is a dash of France. So this AI algorithm is telling me, hey, the best thing that can fit here is capital. So it's generating the kind of test data for you. The goal of life is dash. So it looks like, okay, happiness could be a probable probability is the highest. Okay, this data can actually go there. So behind the scenes, what it is using is actually using an algorithm called as GANs, which is Generative Adversarial Network Model, right? Where you have training samples which are fed into the AI. You're pushing in and asking in, hey, what should be the data that should go here? And it generates you the samples, right? The other thing is called combinational permutations. You might have learned this in your engineering as well. So if there are possibly 4 combinations of the first element, 4 possible combinations of second element, the possible highest coverage that can happen is 4 cross 4, which is 16, right? So this is actually using the combinational permutation algorithm. The last one I would like to end is with result collation. While applications of AI are many, I would like to stick to top 7 in the interest of time. So result collation, it has traditionally been an Excel file with pass, fail, blocked and things like that, right? Which is very shallow in terms of even getting a clear picture of what you really want to do, right? So modern ways of using AI is using dashboards where you collate information, where you get execution history, where you get coverage percentage, where you get the number of defects log, right? So this has been very useful if you are using the power of AI for activities like result collation. So here's an example of an text summarization AI API where you give a summary of a particular text, and the AI actually computes for you that, okay, hey, this is the relevant data that you need to use. So what's actually happening behind the scenes when you talk about result collation, right? It's using actually the thing called as hierarchical algorithmic clustering algorithm.
Excuse me, sir.
Yes.
Sorry to interrupt, but we have only a few minutes left. Thank you. Sure.
I'll be ending it in 3 minutes. Okay. So yeah, it uses HAC, which is hierarchical algorithmic clustering, which uses a bottom-up approach where It collates the relative important data, and then it gives you the result there. Okay. So quick summary, we looked about the element identification using decision trees, KNN analysis, action logic creation using NLP, discovering new tests using training neural network models, visual testing using computer vision, self-healing using multi-class K-means clustering algorithms, test data using generative adversarial network, computation combinations, and result collation using hack. So I'd like to end it that, not every AI is superior. AI can also go wrong at sometimes, right? The classic example is of Microsoft AI chatbot, Traytold, which didn't last for even 24 hours when it was launched on Twitter. There are examples of AI going wrong with self-driving cars as well. This was an example of Uber, where it actually led to a deadly crash. So while AI cannot completely replace humans, it's time for us to actually use AI where we think it can add value to us and our efforts. So AI is neither good nor evil. It's a tool. It's a technology for us to use. So embrace AI, because AI can enable humans to focus on parts of their roles that can add most value. So I'd like to end my talk in my 25 minutes. You can connect to me on LinkedIn, Twitter, and my YouTube channel. You want to learn more about XLQ, which is an AI-powered test automation platform. You can get in touch with me, or if you'd like to join a community of test automation enthusiasts in Q community, you can always DM me. I thank GTA ATR for giving me the opportunity, and hope you enjoy the rest of the sessions.
Hey, Geosley, it was just a wonderful session. So we have one question in the chat. The question is, does SLQ support load testing and performance testing?
Yes, so we are going to introduce performance testing starting next year. So that is something that we will support. Yeah.
Yeah, so thank you so much, sir, for sharing your views, and please